Now let's see how can we use a graphing utility to approximate local maxima and a local minima and to determine where a function is increasing or decreasing. So let's look at an example. Use a graphing utility to graph this function. Okay, f of x equals 6x to the third power minus 12x plus 5 for x in this range, -2 less than x less than +2. Approximate where function has a local maximum and where function has a local minimum. Okay, that's A. B, determine where function is increasing and where it is decreasing. All right, so we need to use graphic calculator. Let me get a emulator run. So first of all, remember we learned last time, right? In order to find the local maximum, local minimum using graphic calculator, we first have to, input the function, right? Use y equals. We need to get a function in first. So the function is 6x to the third power. To the third power, we use the caret key, move the cursor to the exponent's position, okay? And then press the exponent. In our case is 3. And then the cursor, you see this flashing, that's a cursor, is on the exponent's position. You have to bring it down to the normal position, which is use the arrow key to bring the cursor down, okay? And then we type minus 12x and then plus 5. Okay, double check the function we entered is correct. All right, and then we want to close this window by click second mode, okay, called the quit function. All right, and then we would like to graph this function first, right? So I press the graph button, and then you see we only see very, very little part of it. Do you know what is the problem? Right, it's about the window, right? We didn't set up the window right, okay? So click the window, we need to define this 4 parameter, x minimum, x maximum, y minimum, y maximum, all right? So remember how we determine the window size? X minimum, x maximum is given by the problem, right? Remember, it given the domain of x, right? Which is -2 to +2. Okay, -2, that's for x minimum, +2, that's for x maximum. And then after that, and then we can just look at the graph, okay, see any difference? Okay, doesn't display anything. So that means the y minimum, y maximum, we're still not right. Okay, and then let's do y minimum, y maximum. We really don't know, right? And what will be the y minimum, y maximum. So there's another way we can kind of, find some reference value. Remember last time we also learned the table, right? We can try to look at the table and see. Okay, let me close this window and then press second graph, look at the table. Okay, so when x equals 30 some, looks like this is a huge number, okay, and then that's all the positive number, right? Oh, there's a -2, +2, okay. We have to set a table, second table set. So it's not 35, it's -2, right? Okay, now let's see. Second graph called the table. All right, so now we see when x equals -2 and then y equals -19, and then when x equals +2, y equals 29. So that's given us exactly the y value, right? So we can let a y minimum be -20 or -22, and then y maximum we can do 30 or 32, right? All right, so let's do that. Y minimal, let me do -22. Y maximal, let me do +32. Okay, now let's see. Great, we got a wonderful graph. Okay, so from the graph we can see, okay, we from left hand side, and then just use your pen or mouse, go through it. So we go through, okay, increasing, right? It looks like here have a turning point, and then start decreasing, and then look like around here have a turning point, and then start increasing again. So from the graph we can tell we do have a local maximum and we do have a local minimum exist, right, on the graph. So now how can we find it? We use called the calculate function, which is right here. Okay, so we need to press second trace, okay, to find a local maximum, local minimum. So when I press second trace, and then there's 7 options here. Okay, we would like to use 3 to find the local minimum, use option 4 to find the local maximum. So I'm gonna press 4 first, okay, local maximum. So when I press the 4, you see this a little cross thing, okay, it's flashing. And then that, if you use the arrow key on your calculator to move it, so it's along the graph, okay, moving. All right, so you want to move this cross cursor, okay, to the left hand side of the local maximum you can visualize. Okay, anywhere on the left hand side will be fine. Okay, so that's just define the left hand side boundary. You see the left hand side, the question asks you left boundary, so we given, okay, anywhere as long as on the left hand side of the, highest point, locally highest point over here. Okay, so press enter, and then that will mark the boundary dash line right here. Okay, now asking you to determine the right boundary. Okay, right bound. So I use the arrow key, move this flashing cross to the right hand side. Okay, anywhere as long as on the right hand side. Okay, before this turning point. Okay, anywhere along here will be fine. And then press enter. So place the boundary right hand side. So what it does is ask calculator searching from here to here for the highest point. Okay, we're looking for local maximum, right? So you need to give a boundary where to search. Calculator cannot search, the whole thing, right? So give a range. And then now the question asks you another, do you want to make a guess, which is estimate the result? Of course, that's a purpose, right? So we press enter, like we enter yes. And then this is the local maximum estimation, okay, right here. So you can read the value here. And the problem asks us to keep 2 decimal places, okay? So you need to set the door, right? On the right-hand side of 1, place the door here, and then look at the back door. Who is at the back door? 6, right? 6 greater than 5. So when x equals negative 0.82, and then we have a local maximum, and the local maximum value equals 11.53, right? Set the back door here, and then 1 is behind the door, so less than 5, so we can ignore. Okay, that's how to find the local maximum. Find the local minimum, exactly the same process. Okay, do the second trace, and then now we choose option 3. So now ask for left boundary, right? We know the local minimum right here from the graph. So we need to move this flashing thing to the left-hand side of the lowest point you can visualize. Okay, place enter. So let's place left bound dash line, and then ask for the right bound. Okay, move to the right hand side. Okay, and then press enter, place the right boundary, and then another enter for guess. Okay, so here is the estimated local minimum. So when x equals 0.82, right, round it off at the 2 decimals, and the function has local minimum, and the local minimum value is negative 1.53, okay? The backdoor is here, 1 less than 5, so we just ignore them. Okay, that's how we find local maximal and local minimal. So now let me back to the PowerPoint, and then you can see the solution page. Okay, that's the thing I just showed you. Okay, that's the same graph, right?